Today we have a 2014 Toyota Sienna. I have a little more time today, right now, so I'm going to use it to actually do a little bit better video than I normally do because I haven't taken this kind of time before. I'll show you a little bit of the Fieldpiece software that comes with your manifolds that you purchase. If anybody has bought the S-Man 480V manifolds, this software comes with it. The software also works with all the Bluetooth wireless sensors, pressure sensors. These are pressure sensors. These are contact temperature sensors that you could clamp on to the liquid line or the vapor line. In this case, this has dual air conditioning, so there's lines going to the rear of the vehicle, and you can tell how the expansion valve is operating in the rear and record it and prove to the customer whether they're working it or not. And you can show the customer by taking a snapshot before you perform your work. You do all your corrections, you replace your parts, you do your flush, you do your recharge, and then you can show the customer after. And if there was any dispute of something was or did not improve, if anyone went to small claims court or the Bureau of Automotive Repair or anything, you have recorded hard data that was a live snapshot while the vehicle was in operation off of live Bluetooth readings, proving for a fact what you have performed on that vehicle. Or if you got a vehicle into your shop, or you're a customer and you went to a shop and they didn't quite know what they were doing, you went back 2 or 3 or 4 times and it still never works correctly, you come to a shop who actually has equipment and knows how to use it. They can actually snap record your vehicle as you drive from that other shop that you just got upset at, and you come to a shop who knows actually what they're doing. They can hook up their equipment and data log and report what is in it, including contaminated refrigerant that you often find from shops, and give that customer the paperwork needed to go to court and have it legally disputed so they can get all their money back from the previous shop who did all the bad repairs because they did not know what they're doing. They had nothing to prove what they're doing other than what they wrote down by hand on a piece of paper, where in this case you can actually take the readings right off of all the lines and equipment as the vehicle is running as proof and evidence of what was or was not done and how it was performing before you gave the keys to the customer and they left that vehicle out your door. So here's the Fieldpiece software. I'll go back a little bit. Let's go back. This is the entrance. Let's get all the way out of here and start from zero. This is just a cheap Android. Supposedly the Apple works better. You don't need a new one. You don't need an expensive one. Since we're in automotive, we break things get dirty. This is a child's protector made out of foam, so you could bang it, drop it, and it won't get hurt. And you could order those off eBay or Amazon. I think they were like 11 bucks when I got them. They're a little more expensive if you don't find them on sale. And your tablet just fits inside. So here we're back at the fade screen. Here's the job link software. This is Measure Quick, and also a good one. Here's the blue vac for that vacuum micrometer I've told you about that you've seen in some of my videos. That's the software for this. This is TechLink. This is for an amp meter, and you could do data logging with the amp meter. So that's that, and you can test capacitors, and you could test your efficiency and everything like that using an amp meter. This is Testo's version of Fieldpiece for my Testo probes, and these are the Fieldpiece kit right here. This is the Fieldpiece meter. This is for the Fieldpiece scale. You really don't need this if you have this, because this actually has this built inside here, and you could do scaling and filling from your Fieldpiece scale that is wireless to Bluetooth that connects to your S-Man manifold. So really you don't need this. I just have this because I'm going to use it and show you guys. So Fieldpiece software. Bring it up. Okay, measurements. There's a lot of other features on there. You can even do invoices out of this. It has a simple program software like QuickBooks or something, or Peachtree, or any kind of accounting software and invoicing and sales receipts. Fieldpiece can do that, but I recommend QuickBooks instead. I tried the Fieldpiece, I signed up to it, started using it, I stopped using it. I was not too impressed. It's really, really simple and basic. If you don't want to move to anything other than a simple paper form and you want something as simple as one piece of paper, then you use a Fieldpiece. But if you want your invoices or your paper sales receipts to actually backlog and put data into your bookkeeping, so you could hand it to your bookkeeper at the end of the year and keep tabs on your profits and loss and your return on investment and depreciation on equipment and parts while you're doing things, then you get something like QuickBooks and QuickBooks Online that could run out of your telephone. So here we go. We are hooked up. What do we have here? So everything is already turned on. So right here where I have return and supply, and let's get out of that. Actually, I don't have it on the return. They're both supplies right now. One is hooked up to the front duct dash, out the dash. This is the temperature blowing in your face in the front of the vehicle. This is the temperature, the rear, coming in the rear vents on the passengers in the back. They're the vents that are in the ceiling. My liquid line pressure on the high side, 61 psi. 61 psi. 8 psi on the low side. 8 psi on the low side. So you can definitely say we're most likely very low on refrigerant. This is an extreme case. Look at our superheat. Pay attention to the superheat. 85 degrees on the superheat. Don't pay attention to the subcooling too much. Where do I have it? Yep, I have it hooked in. No, I don't have it hooked in the right position. Actually, on this temperature right here, the 152. The 152 is the temperature of the refrigerant leaving the compressor. I actually hooked on the discharge right here, where you see this yellow clamp. That's hooked on the discharge line of the compressor. So right now, just at idle, and it's not even hot outside. Here's the temperature for the thermistor, and the thermistor is taking the temperature of the air that's going in across the condenser. The temperature right here at this location, ODDB, outdoor dry bulb temperature, 82 degrees. So we have 82 degrees, and there's our outdoor dry bulb temperature, 82 degrees. So that's your temperature there. You're recording that because the outdoor temperature has a lot to do with your high side, your low side, your superheat, your subcooling. So does the airflow of fans and stuff like that. What else? Okay, so this is obviously a very low system, and this is my low side temperature gauge. Or if you don't want to use wires, you could use one of these, and it'll hook up to the software, and you disconnect this and you can use these. And I'm hooked back there. That is the suction line coming out of the front dash of the evaporator. So that is the temperature of the line coming out of the front dash. SLT, suction line temperature, 92 degrees. So there is no leftover refrigerant that has capacity to remove heat left over, and that's why it's so hot. And if I come and take that off of the suction line of the front evaporator, this smaller line right here, this is from the rear. This is from the rear evaporator right here, what I'm touching. So this is the temperature of the rear. If I could get to it somewhere, get to it good. Okay, this is the temperature of the rear evaporator. And then coming back here, our suction line on our rear evaporator is 97 degrees. It picked up a lot of heat. Now, actually, you would not want to take, now this is where you have to understand things. Just telling you what things are is not going to get. Having the tools will not help you unless you have the base knowledge of what they mean. And if you don't know where to correctly place your tools, you will get really bad readings. And this is one of them. This is an example. So setting this up here, we have the hot, I don't have it insulated, so the hot air from the fan and the radiator inside here, it's like 130 degrees or so, is blowing over my probe. And if my probe is up by the exhaust manifold, the radiant heat is actually striking the probe, heating up the plastic that will radiate to the sensor that's on there. Even though the sensor is in contact with a cold pipe, in this case it's not cold, the heat of the plastic will give you a false reading. But I'm just showing you this. This would be one of those cases if you wanted to know what your rear condenser, no, your rear evaporator was doing. You could have no gauges, no manifold, and use only sensors everywhere. You don't even need these. This is optional anymore. Gauges are becoming a thing of the past. You could just use sensors, and for pressure, you just use pressure sensors. And you could go to the rear of the vehicle and hook these up to the rear suction line of the evaporator. And you can actually take the temperature of the evaporator coming out of the rear from underneath the vehicle just by hooking this up, and the Bluetooth would send a signal to your software. So we'll do a quick recovery here. I already did. It was clean refrigerant. It only had 8% air contamination, which is not bad compared to some. And as you can see here, I have one probe here in the rear vent right there, taking the rear temperature, and then one probe here in the front, taking the front temperature. Turn it off. Now when using plug these in. Now when you're using a recovery machine, we're gonna pull off the vapor side. So I open the vapor. This is 1/4 inch, this is 3/8 inch. Open the 3/8, and this is where the 4-port comes in handy on the 460V, because you have this 4-port, and the 4th port is 3/8 of an inch. Your recovery machine, this recovery machine in particular, is 3/8 inlet. So you don't have to have, now recovering through manifolds, you don't even need to do that. You could run this line straight to adapter on the end and recover. But in this case, I'm just using the gauges for convenience. So I'm hooked up there. I'm still cut off. I'm like in the cutoff mode. Another thing, remove any restrictions. If you have port compressors in the end of your lines, make sure your lines are open and there's no restrictions. It's completely no restrictions at all. You don't want any restrictions. So let's put this into the recover mode. Let's turn it on. Not yet, I just remembered something. Let's grab one of the technician's tools. Pliers. Come on, guys. Okay, steel set of tools here. Yeah, how you like my knobs? Even though they're brand new, broke them. Okay, so got that off. We will turn this on. Okay, the scale's on. The Bluetooth is sending signal. Let's turn this on. Okay, let's zero it out. Okay, we are zeroed out. So now this is communicating wirelessly. Let's turn this to the on mode. Open. Press the button. that open up? There we go. Okay, so it's pulling down. It has zero pressure on the side. It's -10. You could watch it right there. Actually, I think it's better if it's like that. So right now I'm only pulling through the low side. Only this is open on the low side. This is open for the 3/8. We're already into microns. So we're that low, that facet is really low. So now we put it into the vapor mode. It pulls down even faster. We will open up the high side because there's like next to nothing in the system. But even though there was next to nothing, this is a large dual system. Look at, so far I have 30 grams that came out. We're into microns, so we know we're really deep vacuum by a recovery unit. This is not a vacuum pump, but yet we're already pulled down to 800 microns. But that's because this is on and there's restrictions right here. So the 800 microns is actually only inside the hoses. If I had a micron gauge hooked up on the other side of the restrictions of the fittings and I put it here, I bet you I'd read like 1800 microns on the other side. And the way you can tell that is you turn off your source of vacuum. There, I turned it off. Let's see if it stabilizes. So I turned off the source of vacuum. Oh, it's still not going up. It's truly in 700 microns. This one pulled down. That's actually this machine. This machine here is unusually better than all other machines on the market for this compact size. We're at 40 grams. I have it in the vapor mode now because there is no liquid in the system, so I turned the knob from up here, turned it around because we're in vapor mode. Now I'm going to set it into the purge mode to clean out all the liquid refrigerant from the coils and push it through the line into the tank. So we're at 40 grams. Now watch what happens when I go into purge. A little bit more because this thing was almost empty. So maybe we go up to 50. Oh, we're just vapor. So that gives you a little bit of the insight of the software that you will get when you purchase one of these S-Man 460Vs. And the software also works with all the optional temperature sensors, pressure sensors, and the other temperature sensors for sticking in the duct dash back there. And there's many other sensors that could go onto it, but this would be your basic kit. And that is it on that. We're in 825 microns in a dual evaporator system on a Toyota Sienna van. And so this is ready to turn off. And that is off. That is off. And so now I'll hook up the 12 CFM vacuum pump that pulls down to 3 microns capability. I already have the 8 CFM Fieldpiece. This is the Navac, and we'll see what we get vacuum wise. Right now, with the system off, we're stabilized at 826 microns with no vacuum pump on the system, just a recovery machine.